Okay, so for this one, I want to do some pseudocode to um, try and understand how we should implement the next portion of this logic. So what we got is, for the pawns, we have logic to grab us the squares that they could potentially move to, right? Now what we want to do is do some increased filtering and say, okay, these are the squares that they could potentially move to. So now for each of these squares, we want to have some logic that tells us if, okay, so it's a potentially legal move, but is it actually legal, right? So let's do some pseudocode. So let me grab a screenshot of this, copy the clipboard, let's add it here, and zoom in. Should we zoom in or make this bigger? I think I want to make it bigger. Okay. So this is from the perspective now from the D pawn. From the D pawn. Get some emergency coffee. So let's do some pseudocode to determine if the D pawn can move to this square. So I'm going to do a 1. Then over here I'm going to say 1. So what do we need to happen for our pawn to be able to move here? It can move there if what? If the square is occupied by dark square or by dark piece, right? But what we also need is let's write this from the perspective of our D pawn. So if it's occupied by a dark piece and the square is diagonal from current position. And it won't throw the king in check. Not in check. Which I think this third part I'm not going to worry about yet, because that's going to introduce some more complexity. So now let's say for this square 2, what's the logic to move there? It can move here if square not occupied. It can move there if, same logic, king not in check, right? What about 3? Should be the exact same as 1. Right? Come on. I have Windows Ink disabled because I strongly dislike Windows Ink. But it forces me to check this draw with mouse or touch. Okay. So 4's got some slightly more special logic. it can move there if square not occupied. Square not occupied. It can move there if, and this is what's special, if piece hasn't moved. And then king not in check. If moving here would put the king in check, we can't do it. So if black has a bishop, on this diagonal, on the A5 to E1 diagonal, E1 A5 diagonal, right? Or I guess this, no, it would just be this diagonal. Then we can do it. So what does this tell us? This is diagonal from current position tells us we need some sort of context. To tell us where this square is in relation to our starting position. So what I would really expect to see is we have a function, we plug in our starting position, plug in this end position, and it spits back a 7. Northwest, right? So we need a function to get direction. And it takes in position A and position B. And the easiest thing is if these positions, like position A, in this example would be 1, 1. No. 1 or 0, 1, 2, 3, 3, 1. It's going to be easiest to get the direction based on the current coordinates. So that's one thing that we can work on is we plug in two arrays. We feed in 2 arrays to this function, and we get position B's position relative to position A. Okay. Another thing is we need a function to determine if a square is occupied. Oh, I guess one other thing that we didn't talk about is for the fourth one, we also have to make sure that that this square right here isn't occupied, right? Not just our destination, but this one too. So what we also want is, once we get our direction, let's say we also want to get, we already talked about needing that function, get in between squares. And we also want one for like square is occupied. And if the square is occupied, what's on it? Right? But for now, I think that's okay. So let me just say square not occupied. And let's say square directly above not occupied. Okay, so let's focus on the function to get the direction. So this function is going to take in 2 arguments. Each argument is going to be a array with 2 values, and we're going to spit out 0 through 7. Let's work on that. And I'm going to be thinking of this from the perspective of this square, of our D square. So I'm going to be referencing this image. So this square, the coordinate is what? 3, 1, right? 0, 1, 2, 3, 1. This square is 2, 2. Okay. Let's build that function. So shrink this down. Okay. So let's say our function get target direction, and we have start chord, end chord. Okay, so we're going to assume that start chord equals what? 3, 1. End chord equals 2, 2, 2. So how do we convert this into this? Or no. X and Y. Okay. No, it's fine. So let's say if start chord at the beginning, which is its X value, is less than end chord 0. That means that, so if the X is less than, if the X of our start position, or let's say if the X of our starting position is greater than the start of our end position, we know it could either be 5, 6, or 7, right? So it's actually structured like, So let's have if it's equal to, less than, or greater than. And for this example, we wanted to do this from the perspective of the start coordinate is greater than, because we want to spit out 7, right? Okay. Start coordinate is greater than our end coordinate, so now we want to narrow it down. Okay. If now let's look at the y value. So start chord 1 is equal to end chord 1. And we're going to have 3 different flavors of that. Start chord's greater than or less than. So in our case, the y value, the end chord y value, is greater than the start chord y value. So we're entering this loop. Then, in this case, return our directions.northeast. Okay. Or, sorry, northwest. Okay, so if start coordinate is greater than the end coordinate on the x-axis, so we could have 6, 7, or 5. So now let's say if the start coordinate is less than... Let me get rid of... Let's see. Let's do that. So this would actually be southwest, right? So in other words, if our y direction is less than our end y direction, we're going down. So it could only be 5. In this case, the only one left is, if they're the same, we just went left. X is less than... I think this is... Let's see, actually. So this really should be in this block. Sorry. If X... Zoom left. Because I'm doing it from the perspective of... in this case, 3, 1, and 2, 2, right? So, or actually, no, I think I had the cardinality right. Let me just copy that and paste it here. And I'm going to get rid of this one and just test. And make sure that we get the right value from this perspective. So get target direction, I would expect to get a 7, right? Start coordinate at X. So this value at first is going to be a 3. This value is a 2, right? And then from this perspective, start coordinate on the Y is a 1. And then it ends up being a 2. So that, oh. So if 1 is, let's see. Yeah. Wait, no. Because we want, the position of the second one, the second coordinate relative to the first, right? So this should really be, if the second one is greater than our first one, yeah, then this is really northwest. And this is really southwest, like that. So what I'm going to do is let start coordinate equals that, and let's do let end coordinate equals that, and then call get target direction. Right? Gives us 7. Cool beans, cool beans. So let's fill the rest of this in. Let me open up our nifty infographic. So, in the second block, if we went in the x direction, we could either have 1, 2, or 3. The end position is greater on the x-axis than our start coordinate. So we could have 1, 2, or 3. So let me copy all of this. Just do, so what if they're the same? We just went to the right, so we went east. What if the start position of y is higher? We went down. We went down, so that's southeast or northeast. Okay, well, that's easy. And now the starting x position is the same, so this could either be 6 or 2. 6, 2. 6, 2, right? What if the start coordinates are exactly the same, what do we want to return? Probably a -1. It didn't move. It didn't move. The start coordinate is greater than the end coordinate. We went to the left. So let's do, we went west. Start coordinate is less than. We went to the right, east. Okay. I'm going to change that to a lowercase g to get target direction. So how do we test this? How do we test this? Where are my events? Oh, right under here. Okay. Okay. Move piece, start click and end click. Before we call this move piece, this is like the last thing we want to call it, right? So before we actually move the piece, we've got a start click and end click, which are the algebraic values, right? So let's call get target direction. And what do we want to pass in? We want to pass in start click. We want to pass in end click. However, we're expecting coordinates, right? We're expecting coordinates. So how can we get around that? How can we actually pass in coordinates? If only we had some helper functions to convert the algebraic notation to the coordinate notation, right? All right. What does that give us? So I actually want to oh, I added that to the wrong place. Let me undo that. I want to actually comment out the logic to move it. I don't want to move it. I don't want to move it. I just want this for now to spit back the target direction. And let's log this. Let direction equal get target direction, and then console.log direction. Okay, now let's see. Let's bounce back over here and see. So my second click should fire this. That's a 7. Refresh it. That's a 1. So let's have our little coordinate system up. And then let me, for now, put this on the right. Right. Look at the console. Start over. They gave us a 2. So that's not right. That's not right. That should be giving us a 0. So get target direction. So gave us a 2. It gave us a 2, which is equivalent to east. This means that we went up. This means that we should be north. This one should be south. Let's try it again. Yes, that's 0. That's up. That's 1. That's northeast. That's northwest. Left. That gave us a 2. Right. What about going bottom left? 5. Great. 3. 4. Okay. What do we have? We're getting a, I guess, cardinal direction relative to 2 coordinates, which is one of the pieces of the puzzle. That solves what? That solves this is diagonal from current position, right? So that's awesome. That's a big part of it. What else do we want to add? And we'll do this in the next section. Next section we'll see, we can do a few things. We can check and see if our target destination is occupied by a piece, and so we can have a function that will just return a piece for a given square. I think that'd be the best thing. We'll just return a piece for a given square, and then if we want to do any additional checks like, did it give us a piece? Yes. What color is the piece? That'll solve a few things. That'll solve is occupied by a dark piece and square not occupied. Right? Till next time.